Okay, in lesson 27, we're talking about related angles, all right? So whenever you draw a picture of a vector, that is polar coordinates, you're always going around the circle to some quadrant. You're either going to the first quadrant, second quadrant, third quadrant, fourth quadrant. Depends on what the value of your angle is. If it's between 0 and 90, you're in the first quadrant. 90 and 180, you're in the second quadrant. 180 to 270 is the third quadrant, and 270 to 360 is the fourth quadrant. And so you go around to whatever quadrant you're in, but the triangle you draw is always supposed to be between the vector, the radius of your vector, down to the x-axis. You never use the angle between your radius and the y-axis. You always use the one between the radius and the x-axis. So depending on what angle you have, you will be using a related angle. You don't use the angle you have, like if it's more than 90, you use the related angle. So for example, if I'm looking at the vector 12, 135, I start at 0 degrees, I twist around all the way to 135 degrees, which means I go 90 and another 45. And then I don't work with the angle 135, I work with the angle 45 to find my x and my y and to figure out the value of the rectangular coordinates for that point. All right, so the angle between the radius and the x-axis is called the related angle. So for 45-degree angles, I mean, there are several angles that have 45 as their related angle. All right, so let's just look at a picture of what I'm trying to say. Over here, if we look at the Cartesian plane to the right, so this circle here with all these angles on it, we can see that all the angles related, we can see all the angles related to 30, 45, and 60. All right, so if you go to 30 degrees, obviously the angle that you're working with is 30 degrees. It's right there in that triangle. If you go to 150, again, you are working with the 30-degree angle when you draw your triangle, because this is 180 and that's 150, so 30 degrees between the angle and the x-axis. If you're working with the angle 210, when you go all the way around from 0, 180, 30 more, you're at 210. That also has a related angle of 30 that you work with. When you start at 0 and you go all the way around to 330, then you are again working with a 30-degree angle. So for 30, 150, 210, 330, the related angle is always 30, the angle between the radius and the x-axis. So all the orange angles on this picture they all have a related angle of 30. And then similarly, if you look at the 45-degree angles, you've got 45, 135, 225, and 315. They all have a related angle of 45. And for the 60-degree angles, you've got 60, 120, 240, and 300. All those angles have 60 as their related angle, the angle between the radius and the x-axis. All right? So whenever you are changing polars to rectangulars, you're paying attention to that related angle. Now, if you punch in cosine 135 onto your calculator, so you go 135 and then you hit cosine. Oops, that was the wrong button. 135 cosine. You're going to get negative around 0.71. Okay, why is it negative? What makes a trig function of an angle positive or negative? Well, the thing that makes it positive or negative is what quadrant you are in when you're dealing with that angle. So look at the angle 135 back up here at the top. All right, what quadrant is the angle 135 in? It's in the second quadrant. All right, so when you're in that second quadrant and you're looking at your x and your y coordinates, think about it. X is negative in that quadrant. When you write your answer, you won't really work with a negative value for x, because when you're working with a triangle, all the values are positive, kind of, because they're all supposed to be lengths. But in the second quadrant, really x is negative and y is positive. You go to the left and up when you're in the second quadrant, which is where that angle is. All right, so that means that when you're working with the related angle, 45 degrees, you've got y is your opposite side, x is your adjacent side, and then your hypotenuse is always positive. It's 12. All right, so in that triangle, your adjacent side is negative. It's got a negative direction. All right, so when you take the cosine of 135, really you're talking about adjacent, which is a negative number, over hypotenuse, which is a positive number. And so you're getting a negative value. All right, so that's why certain angles have certain trig functions that are positive or negative. It just depends on what quadrant that angle is in, and it depends on whether the opposite side is positive or negative, the adjacent side is positive or negative. The hypotenuse, like I said, is always, we always think of it as being positive. All right, so what's going to happen is you're going to notice that in the different quadrants, quadrant 1, 2, 3, and 4, a different trig function will be positive. All right, so think about it. In the first quadrant, you've got, let me make this really big so you can see the signs I put on there. All right, so notice in the first quadrant, your adjacent is positive. It's that the x-coordinate is positive, and your y-coordinate is also positive. All right, so everything's positive on your triangle in the first quadrant. So all the trig functions in the first quadrant for any angle between 0 and 90, all their trig functions will be positive. If an angle is between 0 and 90, all the trig functions will be positive because it's positive, positive, positive. Whether it's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, it's all positive. So it all turns out positive. In the second quadrant, notice when you are talking about your adjacent side of your triangle now, adjacent to your angle theta, it's going left. So it's actually a negative direction. Okay? So when you take something like cosine of theta and you say adjacent over hypotenuse, you're talking about negative over positive. So cosine ends up being negative. And if you talk about tangent in the second quadrant, you're talking about opposite over adjacent, which opposite is positive, it's up. That's y positive, y value. So opposite over adjacent is positive over negative. So tangent is also negative in the second quadrant. But sine, which is opposite over hypotenuse, is positive over positive. So in the second quadrant, sine functions will always be positive. So for angles between 90 and 180, you're always going to get a positive sine function. Cosine and tangent will be negative. All right, in the third quadrant, think about what's happening. X is going to the left and y is going down. So both of them are negative. You can think of them as negative values. Your adjacent side and your opposite side are both negative. Your hypotenuse is always positive, like I said before. So in the third quadrant, tangent ends up being positive because tangent of theta is opposite over adjacent, so it's negative over negative, which makes positive. Cosine is adjacent over hypotenuse, so it's negative over positive, which is negative. Sine is opposite over hypotenuse, which is negative over positive, so sine is negative. So the only thing that's positive in the third quadrant is tangent. And then in your fourth quadrant, cosine is positive because in the fourth quadrant, look, x is positive. It's going to the right, but y is negative, going down. And so your x-coordinate is your adjacent side. So when you do cosine, it's adjacent over hypotenuse, so it's positive over positive, so cosine ends up being positive. Sine, which is opposite over hypotenuse, is negative. And tangent, which is opposite over adjacent, that would be negative over positive, so it would also be negative. So in each quadrant, a different one of your three trig functions that we're studying right now is positive. The first quadrant, they're all positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. And fourth quadrant, cosine is positive. All right? So the reason you need to know this is because you're going to be evaluating these trig functions that are related to 30, 60, and 45 degrees without a calculator. So if you want to evaluate for cosine 135, the first thing you need to do is make sure that you know the ratios for your 45, 45, 90 triangle and your 30, 60, 90 triangle, which I was shocked and appalled to see that some of you did not know these ratios. You have to know this. This is absolutely necessary for this course. All right, so remember your 30, 60, 90 triangle is 1, 2, square root of 3. And your 45, 45, 90, which I'm drawing these horribly, is 1, 1, square root of 2. All right, so for cosine 135, I want to figure out what 4 times cosine 135 is. All right, well, think about it. 135, like we looked at before, is in the second quadrant, and its related angle is 45. Okay, so remember these ratios, 1, 1, square root of 2. So when I take the cosine of 135, I'm in the second quadrant, so I know that it's going to be negative. So it's going to be 4 times negative something. Negative what? Well, cosine is adjacent over hypotenuse, so 1 over the square root of 2. All right, so my answer, negative 4 over the square root of 2. I'm going to rationalize that by multiplying the top and the bottom by the square root of 2. So negative 4 square root of 2 over 2. Reduce the fraction, and you have negative 2 square root of 2. All right, so you're going to be working with all these angles all around the circle with related angles that you are going to know the trig function for because of your 2 triangles. And then you're going to have to know what sign to put on there based on what quadrant you're in. Okay? So, and really what's going to happen now is you're going to really start to relate cosine with your x-coordinate and sine with your y-coordinate, because that's really what happens when you're dealing with the xy plane. All right, so now I want to do negative 2 cosine negative 150. Starting at 0 degrees, I go negative 150. That means go clockwise 90 and 60 more. All right, so the related angle here is 30. That's when you go 150 in the clockwise direction, you go 90 and 60 more. So this angle right here is 60. That means the related angle is 30. You are now in the third quadrant where x and y are both negative. Okay, so when I take the cosine, which I am going to start thinking about as having to do with my x-coordinate, because the x-coordinate is the adjacent side. Adjacent over hypotenuse is going to be negative in that quadrant. Okay, so this is a 30, 60, 90 triangle. So this is 1, 2, square root of 3. So I remember negative 2 times cosine is adjacent, that's square root of 3, over hypotenuse, which is 2. All right, so if I multiply this together, and I'm sorry, I forgot, the cosine of this angle has to be negative, because in the third quadrant, the x-coordinate is negative. That means the adjacent side is a negative value, and so we have a negative cosine for this angle. All right, so negative 2 times negative square root of 3 over 2 is positive square root of 3. All right, so you not only have to know the ratios for these triangles, you also have to know that when you're dealing with using that angle as a relative angle to some bigger angle that's in another quadrant, you've got to remember what sign that cosine, tangent, or sine is going to carry with it. All right, let's do another one. Cosine 300. All right, think about it. Start at 0, go 300 degrees. 90, 180, 270. You've got to go 30 more degrees to get to 300. That's right here. All right, so I went 270. This is 270 right here. And I went 30 more. So what's the relative angle? The relative angle is 60. The angle between the radius and the x-axis. All right, so now this is my 30, 60, 90 triangle. This is 1, 2, square root of 3. All right, it's in the fourth quadrant. In the fourth quadrant, the x-coordinate is positive, the y-coordinate is negative. Cosine is adjacent over hypotenuse. So 5/3 times cosine 300 is going to be adjacent, which is 1, and it's positive because we're positive, the x is positive there, and then over hypotenuse, which is 2, and hypotenuse is always positive. So this is going to be 5/6. All right, let's see, can we have some more of those, or is that all we have? All right, so that's what you're going to be practicing in lesson 27.